Hi everyone, I hope you're doing great today. Today we are going to continue our lesson 11 on understanding the relationship between current, voltage, and resistance. So today is all about practicing Ohm's law. Yesterday we learned about this critical relationship between current, voltage, and resistance, and today we're just going to spend majority of the class practicing calculating the relationship in order to solidify our understanding on the topic. Today, you are going to need your notebook and for sure a calculator. So make sure you take the next 30 seconds or so to take out your notes, something to write with, and a calculator. If you don't have one, then you can also pull one up on online. Okay? And also minimize any other tabs that you might have open in order to minimize your distractions for today's class. All right, so for today, we'll have our agenda will be a do now. We'll do a short reading and plenty of practice problems, an explanation, a few more practice problems, and then an exit ticket. All right, so let's start. So for our do now, in your classwork document, you're going to answer, based on your understanding of simple circuits so far, what factors can affect how brightly a light bulb glows? So we've asked this question already, but we're going to see if we can answer this a little more technically this time. All right, take the next 2 minutes to answer this question. Okay, you can press pause and you're ready, press play to come back. All right, so let's go over your answers. So you could have said a variety of things based on what we've seen so far, but one of them could have been the size of the battery. So when I say size of the battery, I don't mean like the physical size of the battery, but the size of the voltage, right? So how much voltage does a battery have? It could be 1.5 volt battery or 9 volts, 15 volts or so on. So the bigger the voltage, the brighter your bulb will light. The amount of resistance within a circuit as well. We saw that when your circuit has more resistance, the light bulb will be dimmer. And then ultimately also the strength of the current. So because the voltage and resistance are related, if we have a larger current, then our bulb will be lighter, will be brighter as well. Alrighty, moving along. So just a quick review of the quantities and units. So you can copy this into your notebooks so you can easily access it if you have any questions. Voltage, current, and resistance are the 3 quantities that we've been looking at. For voltage, the symbol is V and the unit is volts. For quantity current, the symbol is capital I and the units are amps and is symbolized by the letter A. And then resistance symbol is R, and the unit is an ohm, and it's represented by a Greek letter omega. Again, this is nothing new. I just wanted to put it all in one page for you, so you can easily refer to this if need be. All right. Okay, you can press pause if you need more time to copy this into your notes. We're going to be moving along. Okay, so now you're going to take the next 15 minutes to read the text that's in your classwork document and to gather evidence to answer the 5 questions that are right before the reading. So what I mean is that here in your classwork document, it says the heading reading, right? So the reading is down here, and right before it, there are 5 questions. So as you're reading, you're going to gather evidence to answer these 5 questions. And then when you're done, you can hit play on the video so you can continue on. All right, press pause now. Alrighty, now that you've finished your reading and you've solved all the problems, let's go over problem number 3 to make sure that we're on the same page. All right, so I'm going to model this for you guys, and you should be taking notes of this in your notebook while I go along. All right, so here you were asked how much current can be pushed through a 30 ohm resistor by a 12 volt battery. So we're going to annotate this how we normally would with any physics problem. So how much current, so you're being asked to find current, which is I, so I'm going to write over here, current, and then can be pushed through a 30 ohm resistor. right? So that's how much resistance my resistor has. So I'm going to write this over here. R is equal to 30 ohms. And then by a 12-volt battery, so this is my voltage. So I'm going to write V equals 12 volts here. All right, so these are my three quantities, and they are related together through Ohm's law, which is V equals I times R. Right, and since we're trying to find current, then I am going to divide both sides by R. Right, so then now I have V over R equals my current. Now I'm going to plug in my numbers. So voltage is 12 volts, and my resistance is 30 ohms, and that is equal to my current. 12 divided by 30 is 0.4, and then my units for current are amps. So there is a 0.4 amp current flowing through the circuit. Right, if this is different from what you got, or you were struggling with problems 3 through 5 in the previous part, then you can go ahead and use this as a model to go back and correct your work for those 3 problems. All right, we're going to move along. For the next problems, you're going to take the next 4 minutes to solve the 2 practice problems that are in your classwork document. So you're going to use Ohm's law to solve them, just like we did. So you can also use the modeling I just did to help you solve the 2 following problems. Right? And when you're ready, when you're finished, then come back to the video. I'm going to press pause now. All right. Now we are going to go over this check for understanding. So you're going to do this online independently on this CK12 activity. So this link is in your classwork document. I'm just going to click here and it'll take me to the website. You'll see this show up. Over here, there's a simulation where this is live. You can change what the voltage of this battery is, and you can change what the resistance of the light bulb is. And as we do that, you can see that the current here changes. So you can play around with that on your own. But over here, when you click challenge me, several questions are going to pop up. All right, so for yourself, just answer problems 1 through 4. And if you want to challenge yourself and do all 6 of them, then you can go ahead and do that. All right, once you're done with this, then come back to the video so that we can go over our exit ticket. Alrighty. I hope you had fun doing those problems. Doing online simulations is cool. Alrighty. The last thing for today is our exit ticket. So I just want to read you through this, make sure that we're all on the same page. So you're being asked here that a student wants to determine whether a black box, whether a resistor is ohmic or non-ohmic. They decide to collect voltage and current data to test it. So you're asked, create a label diagram representing the equipment they will use and how they will use it. Meaning, what equipment do you need to measure voltage and what equipment do you need to measure current? Right, we talked about that yesterday, so you can also refer back to your notes to see. And then the students collect the following data over here. Is the resistor ohmic or non-ohmic? Justify your reasoning. So our key point a few days ago was that a resistor that follows Ohm's law is called ohmic. So something that's non-ohmic wouldn't follow Ohm's law. So you have to go through this data to see if the resistor does follow Ohm's law. This part here, you can answer it in your classwork document or in your notebook. And don't forget but please make sure to include a picture of your work for this exit ticket into your classwork for today. All right, well, that's all for today. I hope you all enjoyed this lesson, and I'll see you all the next time. Take care, everybody.